never known. Don't know where it goes, but it's only me and I walk alone. I walk this empty street on the boulevard of broken dreams, where the city sleeps and I'm the only one, and I walk alone. I walk alone, I walk alone. I walk alone, I walk up. My shadow's only one that walks beside me. My shallow heart's the only thing that's beating. Sometimes I wish someone up there will find me. Till then I walk alone. I'm walking down the line that divides me somewhere in my mind, on the borderline of the edge and where I walk alone.
But like, well, maybe then you could actually see it. Like, I know that already, but I was gonna take like complicated questions, and then I started looking at the complicated questions. I was like, every time I look at the complicated questions, I feel like if I just look at the simple questions, then I have context. Yeah, because I think that's important. Like, I need to like get better at explaining things like fast, and I don't know. It really always makes sense in my head, and then I get the answer wrong. Oh, the light just flickered. Like, as soon as you see that, this is like a really simple thing. I don't think it's not a trinomial, is it? I don't know. It's a polynomial, and I don't actually know what it is, because I don't understand what a polynomial is, because I just like kind of try to follow the rules, but I looked it up on the internet and it just showed like a YouTube video about like buying groceries, and how that is what a polynomial is if you fit groceries in a category in your head or something, and it didn't make a lot of sense to me. But so I don't really know what a polynomial is, but I don't know, it just does a lot of things, and it follows rules, and I think of it sort of like squeezing numbers, because they kind of squeeze numbers. Like, you know, if you have a really light number, then it has a lot of things that you can get out of it or something, like it can multiply. If you have this situation, then you would notice that those are the same. 9b minus 5 is the exact same thing as 9b minus 5, so guess what, you don't need both of them. And then you go 3a minus 5b in one thing, okay, and 9b minus 5 another one, and that's done, because these numbers kind of suck and they are heavy and they don't split up, so you can't do anything. Like, what are you gonna do with a 3? It's kind of a bad number. Second simple one, before I try anything harder, is a simple trinomial. This is what it looks like. I also still don't know what it is. And that looks less confusing than that, but it's actually more confusing a little bit, but it's still not that bad. All you need to do with this is notice something, and what you need to notice is that, like, x I don't know, it's not called quadruple, it's called x to the fourth, and then but I think quadruple kind of makes better sense, because that, like, if you have 4 things, they can split into 2s, so like you just have to split those x to the fourth into 2s and y to the fourth into 2s, because you can cut off 4 in half. So this and that, just do this, and guess what, those are there now, and just like this one, just because there was 2, those already exist, so now you don't need to add a bunch more, because you already did them. Now like, basically you can forget about that and forget about that, because it's down here in these brackets now, so whatever you need to do with it, it doesn't need to be done up here anymore. So the numbers that are left is positive 3 and positive 2. The middle number is something, there's an imaginary number that you don't know about yet, and the middle number is going to add to that number, and this, I don't know, the back of the number strings is going to multiply to that number, the imaginary one, and this is easy, because what else makes 3? Like 3 plus 0, and like, you know, it's not going to be 3 things, it's not going to be 1 plus 1 plus 1, so it has to be 2 plus 1 is 3, and then you think, oh, how do you get 2 with multiplication? 2 times 1, wow. And so then you just transfer this. Now you can forget about those, because they're accounted for, I guess, yeah. I still don't really know what I did, but that's the answer. Like, it's done now, because you're not going to split a 1, it's too heavy to split in. You can split a 2, but I don't know, you're not supposed to take it out of these brackets. I said I think it makes sense to have a context. Now I'll explain something not that complicated, I guess, but it's the next lesson. It's 3, and it's called messy trinomial. All you have to do as soon as you see, I think all it is like a messy trinomial, like that just means that it's not a heavy, it's not 1. Like 1 can be invisible. That's how much it matters. It doesn't matter that much. 10 can like divide up into different ways, and kind of it's a splitty number, so that's why it's called a messy trinomial. Like to get rid of that, because you just really want these 3 things there, right? Like that's what the other question was like, and you want it to look like that. So like you're just gonna like, I'm saying like a lot, sorry, I'm not good at explaining this, but you want an invisible 1 at the front. That's how it will be a simple trinomial. So you're just gonna like kick 10 out for now. Like you don't want to forget about it because it's gonna come back, but you're kicking it out of the next line, and because it's gonna go and multiply by negative 7. But you're not taking, see, like you're gonna multiply 10 with this whole thing, but you're not taking this x to the 4th with you because you need that there to be able to do that thing we just did. So like just, I don't know, just it's fine. That's gonna go there, and it's gonna multiply by negative 7y squared. So like just that's negative 70y squared. Obviously that's pretty easy to know why. So that's just don't forget with the 10 completely, but it's fine for now. Then you just go like, you just copy this, so it's just the same. It just travels down. Oh yeah, you see this and you're like, I don't know, this doesn't look very great because this is just confusing. So you just want to like do that same thing, but it's a lot less confusing than that because there's an invisible 1. So it's this, you just like you split those 4s up into 2s. Look at, there's a x squared there, and you need an x squared down here, and this x4 can turn into 2x squared. Then you take care of that, and you take care of that. So it can go like this. Last time where it's one that an imaginary number. Well, it's not imaginary. That's probably the wrong word. I think that actually means something else. I forgot. But it's a number you're gonna find. It's like, I don't know, what's that? A treasure number? Okay. And, multiply it to get negative 70. Just like, don't forget about the y, but forget about it for searching for that number because it's just gonna invade in your thought. So just go like, okay, first of all, the first thing that I think of if I see negative 70 and what it multiplies to make negative 70, it's going to be like 10 times 7, well 10 times negative 7, right? But it can't be that, because then you look over and you need to add something to 33. Well, if you add, like, both of those numbers are going to go down. Like if you add negative 7 to 10, 10 is going down, and 10 is already at a lower number than 33, so you need to find something that's higher than 33, that a negative number can take it down, and that number is 35, right? So 70 divided by 2 is 35. That's pretty easy. So you have positive 35, and it has to be multiplied by a negative number because otherwise it's not going to be negative 70. So it has to be negative 2. And guess what? 35 minus 2 is 33. So that is both of them. Like positive 35 plus negative 2 is 33, which is the same as 35 minus 2. I don't know. I think it's easier to think about it with a minus, but like just think about a number that's bigger than the middle one, and then if it's in the scenario, and then you need to take away a certain amount, and then it's easier to find than trying to do like 10 times 7. But most people probably just understand this like intuitively, and I don't. This is, so like, yeah, anyways, it's plus 35, but there's going to be another thing there, which I'll do in a second, and then minus 2, and then you still have, you already got, remember you took care of that, now you took care of that, now you took care of that, so it's all down here now, but like, you still have these y's here, and that's like annoying, but this is the highest one, y squared, and y squared can split into y, and that will take care of both of them, just like x to the 4th can split into x squared and x squared. It's the same exact thing, so it just goes y, and now you have this thing. But guess what? 10 is showing up again because you have to divide these by 10 because you kicked 10 to the back, and now he's mad and he's coming back. So you have to divide both of these by 10. That 10. That's kind of important. And then, well, this makes x squared 35 over 10 is 7y over 2. Yeah, it's a stupid number. It's not very nice. Then this is x squared minus yeah, that's another stupid number because it's not a whole number, it's a fraction. So, and that's pretty obvious, right? Like people know that if you you can do that on a calculator too, probably. I don't like how this is invading the space, but it'll be short. Basically, now because you've dealt with this 10, but this is stupid because you don't want a fraction in these brackets. So like you want to get rid of this because I don't know why actually, but just because I think it just looks kind of bad. So just like you kind of move the 10 around there, you're just gonna move the 2 and the 5 because these can't go into anything like a hole. So you just move it there and you move it there, and then it goes 2x squared plus 7y, and then 5x squared minus 1y. But remember, this is an invisible 1, so it's just y, and that's the answer to that question. This other one, it's like not that much more complicated, but it's like the most complicated one that I could find. Like it's like I tried to choose like the last question. I'll just start there. So what's up? Okay, it doesn't have huge numbers. Like, so there's kind of like two different types of complicated questions. One is if it has big numbers that you can't. It's called like the thing where you kick the front number to the back. Like it says it's the long method, and if it's really big numbers, you probably don't want to do that because then you end up with a massive like number, and that's stressful. So let me just explain this. Like, you see that these are the same, but you can't do that thing at the very beginning. You can't kick it out because this is squared and this is not squared, so they're not exactly the same. So if you just like do some magic and you turn x minus 5 into an a, it has the same foundation, but you can keep the squared here without seeing as many numbers. I think that's the point. Yeah, it's kind of adding extra steps for no reason. If you could just ignore the x minus 5 or block it out, then you might not need the a, but I think that there's probably a purpose in more complicated math. But yeah, so you just write the exact same thing down. So, and that's the exact same question, and it means the exact same thing. Pretty big, but it's not that big. 8 times negative 15 will be what you have to do, which is not that bad, to be honest. So, like, I mean, it's not like it doesn't have 4 digits. So you do that same thing where you move that and you multiply it by this, and you're left with a squared plus 14 minus 120, which is 8 times negative 15. If you could use a calculator, that's what I just have it already written down. But the thing is, like, I just like punch a bunch of things into the calculator to get around the number using the same thing where I said that you sort of know that it has to be there's like a range that it has to be something that you can get down to 4. Like, you don't just it's not just random is what I'm trying to say. But yeah, so that's for that part. I forgot about these a's, but it's the exact same thing as you're just making this big thing into a little thing, and it's the exact same as x's and y's, and it goes like that. Ignore that. I'm splitting the a squared in half, and it goes a and a there. And like I said, it is positive 20 and negative 6 to multiply to negative 120 and to add to positive 14. So positive 20 minus 6 is 14, and positive 20 times 6 is 120. 120 is not that bad because it's 120 and it's not 128 or something, or 117. This is the same scenario that we had with the 10. Like, the 8 is coming back, so 8 under here and under here, and then you end up with a plus 5 over 2, and I'm not gonna explain why, but a minus 3 over 4. You split. That's pretty obvious. And just like the other one, this is bad numbers. They're fractions. You don't want fractions, so you need to just like move these in front. So it'll be 2a plus 5 in 1, and 4a minus 3. And if you never did that thing at the start, then you wouldn't have to get rid of this a now, but you did switch this for an a, so you can't forget that. That's what makes this a longer or a harder question, because it requires more steps, but they're not really that hard, because you just go 2. Now this is a, remember, because that's like it's pretend a was a pretend thing. A is x minus 5. So look at this: 2x minus 5 plus 5, and then 4x minus 5 minus 3. And this is just the same as any other. This is an old thing, where you just need to do this whole situation, and it's kind of annoying. It's not this one. Just ignore that line. Sorry, because you're just going into the brackets first and do that after. I'm trying to do it all at the same time, but no. Okay. It goes 2x, and then. And this is multiplying 2x. 2 times x is 2x. 2 times negative 5 is negative 10. And then just leave plus 5 there. I'll leave it alone because there's this bracket and I don't know why I ignored that. So then 4x, same exact thing. 4 times negative 20. See, I told you I don't know multiplication. I have to, if I have a calculator, I'm fine, but like I don't know it by heart. Negative 3, same as the negative 5. These are like just like different twins. And now, like, look, this is the only thing that's different. Those are the same type of number, and those are the same type of number. That's why they're twins. So 5 plus negative 10 is the same as 5 minus 10, which is negative 5. So 2x minus 5, 4x stays the same, because, and then the negative 20 minus 3 is negative 23. Yeah, that's easy. Yeah, like, that's the answer, because this and this 5 and 23, they're not gonna budge. So that's it. It's not really that complicated. I don't have anything that's that much more, but this video is already so long, because if I did a complicated question, it might take me like an hour, but I don't know.